Hello, fifth graders. Today we're going to be learning how to multiply a decimal by a 10, 100, and 1,000. So it's fairly simple, but the concept is that you see how the decimal gets larger as you multiply by 10, 100, and 1,000. I'm going to be using the examples on page 131 in your math book, number 9, 15, 16, 17, and on page 132, I'll be using number 27 and 28 as word problems. So let's get started. That's kind of creepy. So here are the notes you need up at the top. Go ahead and pause the video and get those down. It's a pretty simple rule. Multiplying a decimal by 10, 100, or 1,000 makes the decimal bigger. I think this actually is supposed to be a comma for the 1,000. And you move the decimal to the right when you do this. So we'll do some examples on this page and then on the next slide as well. So on your book, number 9 actually has 4 problems. We're going to do that. That's kind of like a tower. I like to call it the Tower of Power. So let's do that one first, number 9. And you see at the top of the tower it has 4 and 23/100ths, and we're going to multiply by 1. That's easy. Mr. B, anytime you multiply anything by 1, it ends up as the same number. So really, nothing changes. There's no zeros. There's no 10, 100, or 1,000, so the decimal stays the same because it's just a 1. Okay, the next one shows 4 and 23/100ths, the same number. Let's make that decimal bigger. And we're going to multiply now times 10 equals. Okay, so you see the rule, it says the decimal should get bigger. So what I do here is I look at the zeros I have, and I have 1, 0, and 10. So that means the decimal here needs to move one space over, one place value over, 1, and then it drops right here. So the new number, if the decimal moves to the other side of the 2, is 42 and 3/10. That's the new number. So let's continue on with the next one. Same number, 4 and 23/100ths. And now we're going to multiply that times 100. And we follow the same rule as the top one. We count the zeros. Here there's 2 zeros. And the rule tells me that move the decimal to the right. Well, I'm moving the decimal to the right. The same as the number of zeros are in this factor of 100. So there's 2 zeros. So now I'm going to take this decimal. I'm going to move 1, 2, 1, 2, and I'm going to drop it right here. So now my new number would be 423. I could say 0.0 or 0 after that, just so you can see that it's a whole number now. So any predictions on what the next one's going to be? Let's see. Let's give myself a little bit more room down here for the next one. Same number again, 4 and 23/100ths. Multiply. This time I'm multiplying by 1,000. So I'm going to move this over, and I follow the same rule. This decimal here is going to go over 3 zeros, so it's going to go over 3 spots. 1, 2, there's another spot. Well, if that's the case, I can always write the number down here. And now I can give myself more room because I need to move 3 spots. 1, 2, 3. There's 1, 2, 3 spots. So now on this empty spot right here, I have to drop a 0 there. And the decimal drops where the arrow ends, which is right here. So my new number would be 4,230. So if we go back to our Tower of Power, which is, you see that the decimal is moving. Here, this one it didn't move at all because we multiplied times 1. Here, the decimal moved one place. So it went from 4 and 23/100ths, it moved one place. On this one, it moved 2 places. And on this one, it moved 3 places. Okay, so that's basically how you do it. We'll do some more examples on the next slide, and then we'll work on a word problem. Okay, for this example, it's going to be number 15 in your book, which is, looks like 94 and 6/10. 6/10. I'm going to multiply that times 1,000. So I follow the same rule. I count the zeros. There's 3 of them. So what I'm going to do now is, now that I know how to do it, I'm just going to drop the number down. We're going to come down and write it here. So I have plenty of room to move the decimal. And I have to move it 3 spots, right? Because there are 3 zeros. So it's going to go 1, 2, 3. 1, 2, 3. And then where there's empty spaces, I can add zeros to fill, and the decimal gets dropped right here. So my new number is 94,600. Okay? The decimal moved over 3 spaces. Let's take a look at number 16. Number 16 is 0 and 9. Wow, that's an extra place value that we normally don't deal with in 6th grade. There. 0.9463. That's an extra one we don't do, but we're going to multiply that times 100. Okay? And we do the same thing. We count the zeros, 2 zeros, and that means the decimal place is going to move over 2. This one actually have room, so I don't have to rewrite it. 1, 2, 1, 2. Drop the decimal here. So my new number is 0, 9, 4, and 63 hundredths. I can actually lose this 0, huh? Don't need it at the beginning. So 94 and 63 hundredths. Pretty good. Next one, number 17. Let's change up the colors a little bit. For number 17, we have 0 and 678 thousandths. And we're going to multiply that times 10. Okay, zeros we have are 1. I don't have to rewrite this number because I have plenty of room to move the decimal over 1. And it ends up right there between the 6 and the 7, which makes our new number 6 and 78 hundredths. Pretty easy, right? Okay, now let's work on a word problem. Okay, so we're going to read the problem first. We'll do number 27. Monroe uses a microscope to observe specimens in science class. The microscope enlarges objects to 100 times their actual size. Complete the table to show the size of each specimen as seen in the microscope. Well, what I like to do sometimes is if I see things that are obvious, like this 100 times right here, I know what that means is 100 times, right? Multiplied by 100. So let's see, we got to fill out the rest of this chart. And here's the chart. Here's the actual length, and then as seen in the microscope. Okay, the microscope, it says here. Where does it say that? Here it is, right here. The microscope enlarges objects to 100 times. Okay, so that means that I'm going from these numbers here, and I'm going 100 times to get to as seen in the microscope. So I'm going to have to multiply each of these by 100. Well, I can make this bigger so we can do it a little bit easier. Instead of writing all these multiplication problems out, which I could, right? I could definitely do 0.008 times 100. I can absolutely do that and then count the zeros, which there are 2 of them, and move it 1, 2, 1, 2, and I end up with 8/10. Right? That's one way to do it. The other way would be to identify the 2 zeros up here, which I have, and I know that all of these have to move 2 spots because they're all going to be multiplied times 100, and there's 2 zeros in 100. So all of these are going to move 2 spots. This one's going to move 1, oops, 1, 2. This one's going to move 1, 2, 1, 2. So now I can write my new decimals. This would be 1 and 1/10. This one would be 25 hundredths. And the last one would be 0 and 4/10. So there you see there's my new numbers after they've been multiplied times 100. So that takes care of this problem. The second one says, Monroe's teacher wants each student to draw a sketch of the longest specimen. Which specimen is the longest? Okay, so here are the specimens. I have A, B, C, and D. Which one of those is the longest? Well, I didn't do a good job of lining up my decimals, so let me draw down here so you can see it better. Here's 8/10. Here's 1 and 1/10. Ooh, maybe not. Let's try that one again. Here's 1 and 1/10. Here is 25 hundredths. And the last one is 4/10. And then I'm going to add zeros to fill in everything that needs filled in. 1 there, 1 there, 1 there, and then all those. And I can see which the biggest number is because it's the only number that has a whole number, which is 1 and 1/10, and that's specimen B. So the answer Monroe teacher wants to know is which is the longest? Well, that is specimen B. Specimen B. Bravo. All right, so that's it. Good luck, guys. Make sure you get the notes at the beginning, and thanks for watching. Bye-bye.